Good morning, and welcome to the webinar, Get Guaranteed Message Delivery with Jitterbit's Message Queue service. I'm Kunal Mehta, Director of Product Marketing at Jitterbit, and today I'm joined by Tomidas Pal, who is a Senior Product Manager at Jitterbit. First of all, I would like to start by thanking all of you for your time today. Before we begin the webinar, just a reminder that you can ask your questions at any point during the webinar by using the Q&A button on your Zoom window. So you don't have to wait till the end. If you have questions as we go through the content, please feel free to put in your question in the Q&A section. We'll try and answer as many questions we can at the end of the webinar. With that, let me hand over to Tomidas to kick us off. Tomidas.
Thanks, Kunal. Hello, everyone. My name is Tomidas Pal. I'm a Senior Product Manager in Jitterbit. My areas of responsibilities are primarily the iPaaS platform, API Manager, Management Console, and other areas like analytics and reporting. And I welcome you for the webinar on our new Message Queue solution. So starting with, let's look at some of the environment conditions around the product that we are going to be speaking about. And one of the main areas that everybody's familiar today is the drive towards digitization and automation. And companies and enterprises are today challenged towards maintaining efficiency or growing efficiency in pretty much every area of their endeavors. There's also an explosion of or a large number of applications being delivered on the SaaS or the cloud platforms. So enterprises have a choice of using best of breed applications across the board. And thirdly, there's this whole push towards moving applications from on-premise to cloud. And as you know, this endeavor has started more than a decade ago. And still continuing, we also have a lot of applications completely built full-on cloud native, but still enterprises still have to rely on a lot of applications that are still on-premise or on private clouds. So this is also another some of the dynamics in the market that today's enterprise have to deal with. And then finally, this traditional approach of having all your applications in a monolith or a single architecture, a large architecture scenario is being phased out, and there's an ever-increasing drive towards breaking down these applications into things like microservices and containerization. So as you can see, there's a whole lot of challenges and market wins in the business sphere today that is actually driving or pushing companies towards digitization and automation. Now let's look at a little bit on how much is this true, or is there any data to back it up? Some of the information that you see in this slide is based on the recent Gartner survey. As you can see that out of pretty much most of the companies that Gartner has surveyed, productivity actually ranks in the top 5 initiatives, strategic initiatives, and productivity has been an ever high priority initiative for pretty much every company in working in the technology space and pretty much all the business areas. So that's given. But let's also look at the other aspect of what the companies are actually doing. So more than 2/3 of companies are actually prioritizing automation. And when they are actually moving towards automation, there's a whole push towards artificial intelligence and machine learning and all that we so-called hyperautomation. And then 40% of applications are moving towards more microservices and containerization, which is like moving away from the monolith architectures to using a best of breed of solutions across the board So these are some of the things that are already happening in the marketplace. There's a lot of drivers that are challenges and pressures that the enterprise are going through. Plus, there's already ongoing plans of moving towards digitization and automation. Now, so the trend is very clear. The goals are also very clear about today organizations cannot afford to stay stagnate or stay still and make a decision on something that you can do it or defer things for a future. You have to act now, because that's the marketplace challenge that we are actually dealing with today. However, the reality of achieving the goals requires a lot of support from both internal and external partners. And as you can see that there's a huge amount of stakeholder support or executive sponsorship is required, so that there is more commitment towards and there's more investment being made towards achieving these goals. Secondly, even if you have investments, there's a lot of resource and time and resource have to be spent in achieving these goals. So that's the second part of it. And the third part, obviously, which is the most part, the actual implementation of these. The actual implementation requires many technologies and many systems being interfaced to make things work. Because seldom we are in a monolith architecture today. We have actually spread across applications, spread across systems, and there's a whole push towards digitization and automation. So to actually get it done is also a biggest challenge. So executive sponsorship, there should be resource and money and time spent on it. And then finally, to actually implement this, basically to actually get this thing actually going, even if you have all the resource and sponsorship to get this done, there's also a lot of challenges to actually overcome. And that's where we see that Jitterbit has a big role to play. Now let's look at what Jitterbit actually offers in the digitization and hyperautomation space. As you know, Jitterbit actually started as a traditional iPaaS platform and actually one of the leading iPaaS platforms in the world. But then we were not just iPaaS. Eventually, we grew towards supporting the entire sphere of hyperautomation or digitization, including things like API management, be able to create and publish APIs. We also added EDI capability for large enterprises who still are on EDIs. So EDI on the cloud is a major area, product area that we have. We also have the low code initiative. So there's a lot of push towards low code or no code. So we have LCAP capabilities added to our platform. So as you can see, that Jitterbit is very well placed in the sphere of supporting integrations and supporting this whole goal of digitization and automation with all the different product areas that we support, including iPaaS, EDI, API management, and low-code workflow solution. Now, moving on to the aspect of the third aspect, which I actually mentioned about, even if you have all the sponsorship and all the resources, if you have all the money in the world, you still have to get the technology to work. And that's actually means you have to overcome a lot of challenges. And one of the key pieces of making all these things work is communication, because information is flowing through multiple systems, and be able to manage them, streamline them, and be able to have information available at the time you need it. It's a key aspect of supporting automation. Now you can see that some of the challenges of this large number of cloud applications, which means the challenge or the need to integrate pretty much many applications in a single workflow is very common today. Seldom are you have just point A to point B kind of integration. We actually have every business flow actually touches many applications, and these applications could be in multiple SaaS clouds, could be in on-premise, could be on different private clouds. So as you can see that the workflows are already touching upon multiple areas. And the second part is, as a result of this complexity, there's also a lot of other challenges in the transportation organizations have to deal with, including not every system is going to be up all the time, and there could be downtimes to address. There could be bandwidth issues to address. There could be connectivity issues. There could be translation issues, and so on. And impact on the systems because of large transaction flows is also need to be managed. When you have very sensitive, very high critical applications are being actually managed, a huge inflow and outflow of data is also something that can affect the performance of the system. So this is also another aspect to manage with respect to communication. And then I already spoke about planned and unplanned downtime also need to be kind of managed into the overall architecture of how communication needs to be managed. So which means that this whole aspect of having every system up and running and be able to communicate seamlessly, synchronously, is not a reality that we can always aspire for, because it's really not possible. Maybe in the future, 100% fully engaged communication may be possible, but in reality, there has to be an alternate way to manage these challenges to be able to communicate efficiently between systems. And that's where and also the last aspect of this, even after ensuring all the communication challenges addressed, there is also this concept of how are we ensuring that the communication is actually reaching the intended audience and there is no loss of data or loss of transmission. So assurance or guaranteed delivery is also an aspect of communication that organizations have to deal with today. So looking at all these different challenges of having to communicate across applications, having to manage performance, large transportation needs, and as well as uptime and downtime things to be managed, as well as guaranteed delivery, we think and that puts the case for message queuing. So what is message queuing? Message queuing is a technology that addresses these challenges of synchronous communication. When systems cannot communicate synchronously all the time, or there is no need to communicate synchronously all the time, then the alternate is to actually be able to communicate asynchronously, which means that information can be routed towards a middleware, and the middleware actually manages or takes the ownership of being able to communicate with all the connected parties. And that's where basically what is the message queuing in principle is all about. However, message queuing in practice is a very hard piece to actually implement. Organizations can either build their own message queuing platforms. They can always go and buy message queuing platforms. But in reality, that is also not easy, because you have to now maintain message queuing as a platform to actually be able to support your internal workflow architectures. And I believe that's where Jitterbit, who has already solved made it easier for organizations to communicate seamlessly on our iPaaS platform. That's where I think Jitterbit actually is able to go into the message queue sphere and solve the problem. Likewise, we have done for iPaaS. So as you can see that the message queue solution of iPaaS is a complete cloud offering, which basically takes all the pain out of the users to be able to manage the storage, or manage the memory, or manage all the services themselves. But everything is offered as a part of the Jitterbit platform as a service, where users can just enable the message queue solution, message queue service, and then start using it in your workflows. And the second aspect is that users don't need to worry about the management of any of these backend infrastructure. You don't need to manage these brokers. Typically, you have brokers for message queuing, no storage or any other memory services. Everything is managed on the cloud by Jitterbit's iPaaS platform, which means it's a very simplified way of looking at message queue, where message queue is just like a black box where you just send your information when you want it, and the message queue can be now configured to deliver the information to the receiving applications, whenever the applications are ready to receive. So let's look at a scenario of how this actually will happen in principle. Where does message queue actually fits in? Let's start with the source application, where information is actually being sent by the source, and that's where Jitterbit's source system connectors actually came in. For example, if you're taking information from Salesforce and sending it to another platform like ServiceNow, typically you will have something like a Salesforce connector, which will actually get the information from Salesforce. Instead of sending it directly to the receiving application, now you send that information to a Jitterbit MQ connector. Now, the Jitterbit MQ connector is a two-way connector, which can actually receive and send information into the queue, as well as retrieve information from the queue. So in this case, you're sending into the connector now sends it to the message queue service, which is the cloud service, message queue service of Jitterbit. The MQ service, we call it, the MQ service will now manage the storage and queuing of all this information that's into the message queues. And that's it. That part is completed. So the one transaction of receiving the information from the source is complete now. I mean, now there is no need for the source to now wait for the receiving system to receive it, because once it sends it to the queue, the part of delivery is completed. Now, on the other side of it, message queue now starts interacting with the receiving system via, again, the connector. The connector can be configured to retrieve information at regular intervals, could be immediately as part of the transmission. And now Jitterbit MQ connector can now send that information to the target system connector, which will deliver it to the target. Now, we might think that this is a full flow, but it also ensures that there is an acknowledgement sent back to the message queue whenever information is actually retrieved from the message queue and delivered to the receiving system. So which means that there is this concept of whether the information has been delivered to the system or not. So there is a clear audit trail on information went into the queue, and the information is queued up, and then the information is now delivered to the receiving system. And there is also a clear audit trail on system has been delivered, and there's an acknowledgement back. So this is the whole piece of how message queue as a service fits in a typical workflow. Let's go to the next slide, which kind of talks about the few use cases or the few capabilities on what the message queue actually offers. We already talked about the guaranteed delivery concept, which is basically once you deliver the information or the data to the receiving system, there is a clear acknowledgement sent back by the connectors which is actually based on the delivery. So it guarantees your delivery to the receiving system, and it also sends, if the delivery cannot go through, or for whatever reason, could be that the information itself has an issue in the way it can be delivered. Then there's also this concept of negative acknowledgement. So you can have positive as well as negative acknowledgements. The negative acknowledgements can have different ways of either re-delivery or get the information from the source and so on. So that those are some of the capabilities what message queue actually offers. The second capability is basically message throttling, which is basically in a way saying is that when you have large spikes of spikes in data transmissions happening, which can actually impact the bandwidth as well as the overall performance of the systems. Message queue can be now configured to be able to manage, smoothen the curves. So basically, just like you have this COVID smoothen the curve, you're basically now smoothing the peaks and making it much more regular. So the system can now manage it and also reduces the overall cost of resource costs. It could be cloud costs, could be the on-premise server costs and so on. So it can actually tries to help to smoothen out the load on the system. And then asynchronous APIs, we already spoke about the way the source and the target systems don't need to be always talking to each other at the same time. They can be, even if they are at different times, they are up, and the message queue makes sure that the information is transmitted from the source to the target. So that's this full concept of asynchronous communication is managed. Message tracking is the complete audit trail, where basically, in case of message transmission, there's clear trail on where the message is at any point in time and whether it has been delivered, not delivered, whether it's waiting for acknowledgement and so on. So that's the whole audit trail is there with respect to connectivity. And then dynamic routing is going this a level up, basically, depending upon where depending upon the different needs of the organization, messages can be routed to multiple applications or multiple systems, including load balancing. So accordingly, if you have multiple instances of applications running, depending upon the load, the information can be diverted. It can be programmatically managed. That's dynamic routing. Message prioritization is, you can even have different queues where you have some queues are higher priority than the other queues. So, naturally, when you have a high priority queue that needs to be always delivered and given higher priority, that can also be managed. This is another aspect of message queuing. And then payload encapsulation or encryption, basically it's ensures the secure delivery of messages as well as, and the information is fully encrypted in both transmission as well as at rest. And then finally, push queues is basically a way to, pass the information or keep listening to event-based listening, which is basically that instead of having to go and pull the information, you're just listening to certain transmissions, and then you're pulling the information accordingly. So those are some of the aspects of what message queue actually can support. And as you can see, guaranteed delivery, message throttling, asynchronous APIs, and push queues are some of the initial areas that are MQs, is readily available to support based on both MQ and the iPaaS platform capabilities. We also have, a few other capabilities that we will be working towards. But our idea is, these are the 4 ones, and then the other 4 are already part of the iPaaS platform. Moving on to our next area, which is this is just a case study of how one of our large customers actually implemented message queue. They were a multinational logistics company based in our EMEA region, and they had near real-time requirements to update their warehouse management systems with information coming in from multiple sources. And as you can see that message queue is one of the major middle layers actually that manages this whole connectivity and automation. That we have an app builder which manages all the process workflows, including our iPaaS platform supporting all the different communication to different systems, but then everything getting routed through our agents. And there's also a listener framework which listens to these messages. And finally, the message queue actually manages the queuing and the and the receipt of delivery to the target systems. So it is a very one of the large recently completed use case, as you can see that we already started using, or a lot of customers already started using our message queue solution, which supports their digitization journey. And finally, so I just want to kind of summarize with what are the core aspects of what we're saying what message queue would actually provide would be, it helps you to simplify your workflow. Until now, we've been always, managing workflows with respect to synchronous communications. Now we are going the step ahead and making it asynchronous. So instead of having to write multiple, programmatic conditions, message queue service actually, makes it easier to make your workflows, simple, and also, helps you to do asynchronous communication. Guaranteed message delivery is inherent as part of message queue. So that's something that is will be immediately beneficial on workflows that use message queue. Obviously, increased performance of all your processes, all your systems, because message queue tries to address throttling and efficient delivery and all that. Actually helps to minimize cost of processing, and then finally, you gain, all the security features of our iPaaS platform are inherently built into our message queue service also. So those are some of the core benefits that actually comes as part of Harmony. That concludes the overview about message queue, and ready to address any questions you may have.
Thank you so much, Tomidas.